Hello, I welcome you all in this presentation. This presentation is based on the flash butt welding process, and this presentation is also related with the subject joining technologies for the metals. You know that this process falls in the category of the resistance welding process, and we can say largely the joint is formed in the solid state by forging the joints together, forging the components to be joined together. So, we will see that how this process works in, and in which way the joint is formed, what kind of components are commonly joined. So, the process flash butt welding. So, basically this process is a resistance welding process, where primarily the heat for preheating purpose is produced through the I square RT heating principle. But the total heat required for development of the joint is a combination of the resistance heat plus the arcing or flashing heat, the heat which is generated due to the flashes. So, both these are used for increasing the temperature of the workpiece to the required forging temperature, say 1250 degree centigrade for steels. So, basically we need not to have the fusion state for development of the joint, but it is mainly the heating to the forging temperature as per the metal system, say 1250 for the steels, the kind of temperature which is needed for this purpose. We each like preheating through I square RT heating and the heat generation due to the arcing, both these have their own specific role for development of the joint. Since this process is one variant of the solid state process also. So, say as the joint is not formed in the by melting the fang surfaces of the base metal, but joint is formed by forging the components to be joined together. So, this process uses no, you can say, filler metal. There is no filler metal and no you can say no large scale melting of fang surfaces for weld metal production. Whatever melting takes place, that is primarily for the cleaning purpose, and so that the metal to metal contact can be established when the things are forced together. So, no large scale melting of the fang surfaces for producing the weld metal production. At the same time, this process relies heavily on the pressure for forging and for heat to reach the recrystallization. So, like in any other like other welding processes mainly rely on the heat, so that the fang surfaces can be brought to the molten state like this, application of the heat through arc or through the gas flame. So, that molten state is achieved, and under the gravity conditions the solidification is achieved, so that metallic continuity can be obtained. But in this case heat is used for increasing the temperature of the fang surfaces to the forging temperature, and pressure is used for the forging purpose. So, heating to the forging temperature and pressure application for forging the members to be joined, so that metallic continuity can be obtained. So, this is what is there in the basics of the process as a whole. How does it work in That is what and now we will let you know in detail. So, this process in this process one work piece or the members to be joined, say one piece is kept fixed like say with the help of the copper supported clamps, and another end is kept movable. Say this is the movable part or another work piece to be joined which is kept movable, and this is also clamped with the copper shoes. So, this can move back and forth and both are supported on the suitable structure. So, here initially so this one is fixed and another is can be moved towards the workpiece and away from towards the fixed component and away from. So, this is also of the copper clamp. Since the it is of the copper, so because these copper clamps apply pressure as well as deliver current to the work pieces for the flashing or for the flash butt welding process. So, how does it start? Initially the members are kept away like this. In stage 1 they are separated, then in very controlled way the movable part is brought close to the fixed one, so that there is a connection between the metallic contact between the two, and in this stage when the two are in contact, the contact will be through the peaks and valleys present at the interfaces both the sides, and at this stage the current is fed. So, when the current is fed, the flow of current of course will be taking place from the clamps, the two ends and between these two. So, the flow of heavy current I square RT heating takes place. So, during this heating what we will see, during this heating this causes the preheating of the ends being joined. This is one thing. At the same time, since the contact is very localized, so what we will see, contact is very localized, so excessive heating at very localized points can take place, for which can cause the partial melting of the peaks and partial melting of the peaks. So, initially when there is a contact, preheating of the ends of the workpiece takes place, and this preheating becomes complete, means this entire section of the entire end of the workpiece will be preheated in the preheating stage when they are brought together. So, this is what happens in the stage 1, and thereafter the movable end is brought apart. In addition to this, the flow of the current is very high. Here the current which is allowed to flow may be say 20 to 50,000 ampere, and the voltage is quite low, maybe 5 to 20 volts. So, the very low current and high very low voltage and high current is allowed to flow through the work pieces. Since the section size is large, so the resistance will be limited to have enough heat generation. The current has to be too high, and then it is allowed to then the current is allowed to flow for some time. So, through I square R heating, preheating can take place, and then movable component is moved apart. So, what we will see after this preheating, we will see that in the stage 2 they were brought in contact. In stage 3, in very controlled way the members are moved away from. So, whatever whenever there was contact, so this these members is moved apart. So as soon as, since there was a voltage of say 15 volt and flow of current was of say 30,000 ampere, as soon as the movable component starts moving away from, we will see that heavy arcing or flashing starts. This arcing and flashing causes so many things, like if this is the end of the workpiece and here between the two heavy flashing is taking place, then all these impurities, oxides, like in case of the iron Fe2O3 or FeO or Fe3O4, whatever oxides are there, they will be melting. So, all the impurities, oxides under the influence of heat, so they will be either evaporated, melted, and thus they will be removed. So, this flashing will be basically cleaning the surfaces of the component to be joined, and once this flashing is over, so once this flashing is over, in the fourth stage the component once the flashing is over, so during this period there will be rise in temperature of the due to the flashing and arcing for a short while. There will be heat generation due to which impurities, oxides, etc. will be evaporated, melted. At the same time the ends will also be heated, and this will continue until we will see that the rise in temperature, means ends reach to the forging temperature. Say in case of the steels it is 1250 degrees centigrade. Once this temperature reaches, the ends are brought together, means with the pressure the ends are brought together or in close form contact. So, this is what we say upsetting stage. In the upsetting stage, the ends are forged together with the heavy pressure. So, the firm metal to metal contact between the two is established. Say this is what is heated portion with the all molten oxides and impurities. All these, when the forging takes place, all these are removed and the softened end tends to take altogether different shapes. So, we will see that the impurities are getting pushed away in form of the flash towards the outer edge, and this is the kind of. So, here we will see that oxides and impurities are localized at the ends, and here at the perfect metallic continuity is obtained. So, this increase in localized increase in diameter is termed as the flash, which will be coming out, or this is the upset region, and the impurities will be localized in this region, and thereafter once the joint is formed, and this upsetting basically happens under the forging conditions, the metal near the ends becomes soft. So, under the forged conditions it gets upset, and while the remaining sections while the locations away from the interface, they remain at lower temperatures, so they do not get upset, or they do not experience the change in the dimensions or upsetting. So, this is how the joint is formed. Impurities will automatically be localized here under the optimal set of the pressure and the temperature conditions, and this the flash is subsequently removed through the post treatment or post machining operation for developing the proper for achieving the required size and shape. So, now we will see. So, this is the these are the basic steps, and this is what happens in case of the flash butt welding for developing the joints between the members. So, there are 4 stages. One is preheating, second is like say flashing, fourth is third is upsetting or butting under pressure, and then hold. In the hold stage, the two components after upsetting, they are kept together under pressure for certain time, so that the joint can be formed, and thereafter the things are taken off. So, this is these are the 4 steps related with the flash butt welding, and now we will see that in which way the things happen one by one, like say in respect of the like say here this is time, and we may have like pressure and current. So, like this. This is what also we can explain using this diagram. So, here we can use this also. Schematically, the 4 stages have been shown here. Initially, in the initial stage, the parts to be joined are kept on the 2 clamps of the copper shoes with the proper position. So, in the initial stage, this is the position when they are brought together. Initially, like say initially we may have preheating or may not have. So, in case of preheating, entire the ends of the workpiece are heated, while in case of the flashing only the interface zone is heated. So, the flashes are there, flashes will be melting the impurities, removing the oxides and other impurities. Once the required required forging temperature is attained, the ends are the components, movable components is brought towards the fixed component, so that all the impurities are expelled out from the interface, and then upsetting happens. Whenever upsetting happens, we will see that localized increase in the dimensions. So, these 3 all these stages have been shown here. Like stage 1, there is no flow of current. In the stage 2, the 2 components are brought in contact with each other, flow of current starts. So, this will be resulting in the preheating of the ends of the work pieces, and thereafter as soon as the component starts moving, flashing starts. And in case of the flashing, so here 1, 2, 3, this is the stage of the preheating, and in the stage 4, once the flashing is over, the forging is done, so that there is in case of the forging, the 2 components will be coming close together, all the impurities will be expelled from the interface, and the upsetting will happen. So, this is what we can see under the as far as displacement is concerned, there is continuous in the initial stage there is no major displacement 1, 2, 3, but in the upsetting stage there is significant displacement happens. So, as far as the force and the displacement is concerned, this is the kind of variation, and if we will see this is what happens actually at the interface. In the initial stages, when there is a contact through the peaks and valleys, so heavy flow of the current through the peaks and valleys causes very localized heating, and the oxide layer will be getting heated, and when this happens, means the arcing and sparking continues for long, it results in the layer of the molten metal, wherein having the oxides and other impurities, at the same time nearby the heated region is also formed. So, once this is achieved, the things are forced together. So, all these impurities and the liquid metal is taken off or expelled from the interface, and it will the softened zone will be subjected to the upsetting to have the direct metal to metal connection. So, this is what we will see the different stages which have been shown. In the initial preheating stage, in the stage 1, when there is a flow of current, in the preheating stage there is a continuous rise in temperature, and then temperature remains constant in the stage 2, and once the flushing is over and upsetting starts, the temperature starts coming down, as a function of the time, or this also the burn of a period, and as a function of distance, if you will see from the interface. So, at the interface like this, if this is the interface, the point 1, point 2 and point 3. So, the kind of variation in temperature, temperature will be higher at 1, temperature will be somewhat lower at 2 and at 3 like this. So, in stage 1, stage 2 and stage 3, when this is the upsetting stage, once the heat generation and all that is over, this is the flushing stage and preheating stage. So, this is the kind of variation which takes place, and this is the period when the flushing is the required temperature is achieved, and at this time only efforts are made so that the upsetting can be done in very proper way. Now, we will see the kind of variations which take place during the welding in respect of the time and the pressure, So, here this will be showing displacement. Displacement is about the kind of movement here, workpiece, and this is the another workpiece. So, how the movable end moves towards the movable workpiece moves towards the fixed end. So, that magnitude keeps on increasing. So, this is what we will be showing here. So, this displacement is found to be like this. So, this is the upsetting stage, and this is the flushing stage. And the upsetting stage. So, in case of the flushing, we will see this is the flushing current variation goes in like this. So, both these will be moving together almost. Yeah, like this. So, this is the current variation, or you can say this is this one is displacement, and this is the current variation during the welding. So, here if we will see, once the here this is the period when the our flushing will be occurring, there will be continuous rise in temperature of the ends of the workpiece, and then the upsetting force is applied. When there is a upsetting force, there is a rapid displacement. So, what we will see that the burn off period and upset. So, this is the magnitude which will be indicating the displacement corresponding to the upsetting displacement. and this is corresponding to the here the displacement, yeah. So, this one this is corresponding to the flashing displacement. Enough scope is kept for the additional lengths corresponding to the flashing as well as the upsetting displacements, and if we see the kind of variations which take place in the temperature, right, at the interface or increasing distance away from the interface, then typically the weld thermal cycle or thermal cycles which are experienced at the interface, we will see the continuous decrease in temperature as a function of the time, like say here the temperature, and in y axis the time, and then you will see like point 1, 2, 3, 4, say at each interval of the 2.5 mm. So, the one at the 0 distance that is at the interface experiences direct cooling, but the points which are away from, they will be experiencing thermal cycle like this, the point 1, this is point 1, point 2 at 2.5 mm distance, and then point 3 taking somewhat longer period, point 4 further taking longer period. So, the peak temperature and the time to reach the peak temperature, they are also longer. So, our time actually comes like this, time to reach the peak temperature. So, here depending upon the kind of metal systems, the heat affected zone may be of the different sizes. So, this is what we can obtain, we can see from the weld thermal cycles. Now, we will see what are the typical applications for this process. The typical applications of this process includes, like most commonly it is used for the joining of the rails. In addition to that, it is also used for the joining of the rings of the large diameter. At the same time, it is used for the joining of the chains and girders, and in addition to that, these are also used for joining of the pipes of the large diameter. So, here now I will conclude this presentation. In this presentation, we have talked about one of the resistance welding processes, that is the flash butt welding. This process is mainly used for the joining of the symmetrical section components, and this process works on the principle of the electrical resistance heating plus the flashing or arcing for increasing the temperature of the ends of the work pieces to be joined to the forging temperature, and thereafter upsetting results in the development of the joints. This typical kind of the temperature for a steel is 1250 degrees centigrade, and upsetting is done using the temperature using say 90 or 100 MPa pressure, so that the joint is formed. An optimum combination of the current, time and the displacement results in the clean weld, and this process can effectively be used for joining of the like rails, rings, chains, girders, pipes, etc. Now, thank you for your attention.